Hello friends, this is the fourth video, and in this video we are going to discuss about shortest job first, preemptive scheduling policy. Right, so first of all I'm going to tell the difference between the preemptive and the non-preemptive. So in the previous video we did non-preemptive scheduling policy. So in that video I told you that in the non-preemptive we do not require remaining time, right? But in this you can see here we require remaining time. As same as in the non-preemptive, here we look for the minimum burst time, right? We look for the shortest burst time. But the difference here is, the difference in preemptive is we stop or we preempt the execution of processes, the execution of a process under one condition, right? That is, if the newly arrived process has a minimum burst time, then the remaining burst time of the currently running process, then what happens? We remove the current process and allocate the new process, right? So I'll write it here. You can note it down. If the newly we remove the current process and allocate the new process. So that is what happens in preemptive shortest job first. As same as in the non-preemptive, we look for the minimum burst time, but the only difference is if the newly arrived process has a minimum burst time, then the current running process, then we remove the current process and allocate the new process. So that is what happens in preemptive shortest job first, right? So now let's draw the Gantt chart. Right, so here you can see that no process is arriving at 0, right? No process is arriving at 0. That means you have to mark that 1 millisecond in the Gantt chart like this and start from 1. Right? So now from P3 and P5, which has the minimum burst time? It is P3, right? But here what happens? We cannot place P3 fully here, right? We are going to place part by part of the process. So let's do it one by one. From P3, I'm going to place only 1 here. That means 1 plus 1, it is 2. And you can see from this 4, we took only 1 and we have 3 remaining, right? We are doing 1 by 1. And within this 2 seconds, right? Within these 2 seconds, we can see that P6 also arrives, right? So now we have P6, P5 and P3, right? P3, P5 and P6, because P3 have 3 more and P5 also arrived at 1, and now P6 also arrived, right? So from these 3, who has the minimum burst time? 3, 5 and 2. Yes, it is P6, right? So we write P6 here and we take only 1. Let's take 1 and 1 remaining, right? Now within these 3 seconds you can see, so now within these 3 you can see P4 also arrives, right? So now we have P4, P5, 6 and 3, all 4 processes we have, right? So now let's see from these 4 processes who has the minimum burst time. Who has it? P6, right? So now we place P6 here again and it becomes 4 and the remaining time is 0. That means we are done with P6, right? Now what happens? Within these 4 seconds, you can see P2 also arrives, right? So now we have P2, 3, 4 and 5, right? All these 4 processes we have. And we have to select the minimum burst time from 1, 3, 3 and 5. So it is obviously P2, and now we are going to place P2 here, and the burst time is 1. So there's no remaining time. I think you understood that. And we are going to place this P2 fully here. That means 5 and we are done with P2 now. Right? It was only 1. So we placed the whole process fully here. And now what happens? Within 5 seconds, no new processes are arriving and we have to select from these 3. P3, P4 and P5. So here we can see that P3 and P4 have the minimum burst times and both have the same value, 3 and 3. So in such a situation, what we do is we can apply first come first serve, right? So we are going to apply, in such a situation we are going to apply first come first serve. So I discussed what is happening in first come first serve in the previous video. So if you haven't watched them yet, you can watch them. The links are given in the description. So from these 2, who arrives first? Yes, it is P3, right? So we are going to place P3 here. And here also we place only 1 from these 3. So it becomes 6 and the remaining time is 2. Right? Right. Now again within these 6, no new processes are arriving. So we have to select from P3, 4 and 5 to 3 and 5. Right? So from these 3, obviously it is 2 which is the minimum value. So we place P3 here again and we take only 1, right? 7 and 1 remaining. And now you can see within this 7, P1 also arrives because its arrival time is 7, right? So now we have to select the minimum burst time among these P1, 3, 4 and 5, right? So from these 4 processes, P1 and P3 has the minimum values and they are 1, right? So now here also we are going to apply the first come first serve. Yeah. So from P1 and P3, who comes first? P3, right? It is 1. So we are going to place P3 here. And it is only 1 remaining. So we take that here. And it is 8. And remaining, no remaining. So we are done, completely done with P3 as well. Right? And now you can see within this 8, no new processes are arriving, right? So we have P1, P4 and P5. So from these 3 processes, 1, 3 and 5, which has the minimum burst time now? It is P1, right? So we place P1 here. It is only 1, so we fully apply P1. It is 9 now, and we are completely done with P1 as well. Right. And now we have P4 and P5. So from these 2 processes, P4 has the minimum burst time. That means we are going to place P4 here now. Right. And here what happens, you can see that P4's burst time is 3. Right. And no processes are going to arrive now. And P5 has a burst time of 5. So here you can see that 5 is obviously larger than 3. So this 5 is not going to interrupt P4. In such a situation, what we do is we completely execute P4, right? Because P5 is larger than P4 and it is not going to stop the execution of P4, right? So we place P4 here completely. That means 9 plus 3, 12, and we are done with P4. No remaining time left. And finally we place P5 and it is 5. 12 plus 5, 17. So this is the Gantt chart for the preemptive SJF. Now let's check whether our Gantt chart is correct, right? So get the total of the burst time, the original burst time, not the remaining, the original which was given in the question. So here it is 16 and here you can see it is 17, right? And now what happens? Here I told you no processes arrived at 0, right? They arrived at the first 2 processes, they arrived at 1. So now what we have to do is we have to subtract this 1 from this 17 because no processes are here. So the answer becomes 16. Right? And now the answers are similar. The values are same. That means our Gantt chart is correct. Right? That is how to draw the Gantt chart. And now let's get to the next steps of finding the waiting time and the turnaround time. Right, let's start with finding the waiting time. And now you are very much familiar with the equation. So I'm gonna write it in a short form. Waiting time equals visiting time minus arrival time. Right? And we are going to apply this same equation but in a bit different way. So let's start with P1. So P1, it is visiting time is 8 minus arrival time is 7, right? So the answer is 1. Then P2 it is 4 and arrival time is also 4, so the answer becomes 0. And then P3 is there in the Gantt chart for 4 times. So what happens then? So let's move to the first P3, first part. The visiting time is 1, right? 1 minus, so here the arrival time is 1, right? And then we have to add the other parts of P3 also, the other waiting times of other parts. So let's move to the second part. And here what happens, we have to write the visiting time, right? Visiting time 5 minus the right value of the first part. So this is the second P3 here, right? So we have to write the visiting time of that particular part, that particular process, minus the right value of the previous part of the same process, right? So here it is 2. So 5 minus 2 plus, let's come to the third part. It is 6 here. And here you can see the visiting time of this part 3 is 6 and the previous part's right side value is also 6, right? So that means the answer is 0. 0 plus, here also you can see 7 minus again 7, right? Again it is 0. So the answer is 3, right? Then P4, it is only once, so it is 9 minus 3, which is 6, and P5 also only once, so it is 12 minus 1, which is 11, and finally P6. P6 also you can see that it is there for 2 times, right? So let's take the first part, P6. So the visiting time is 2 minus arrival time is 2 plus the second part, right? The second part. So second part you can see the same happens as in the P3. The visiting time of the second part is 3 and also the right value of the previous part is also 3. So the answer becomes 0 here again. So the answer is 0. Right. So now let's get the total, which becomes 31, and now the average waiting time is 31 divided by the number of processes. So here it is 6 and the answer becomes 3.5 milliseconds. Here also milliseconds. Right, so that is how we calculate the waiting time. So how to calculate the waiting time of a process that has been in the Gantt chart for several times? The first part, we have to write the visiting time minus arrival time as usual, and the other parts we have to do, what we have to do is we have to write the visiting time of that particular process minus the right value of the previous part of that process, right? So that is how it goes, and now let's move to the turnaround time. So here the equation is turnaround time equals waiting time plus the burst time, right? So you have to add the burst times of these processes, the original burst time, so you have to add, right, not these second values. Right, let's start with P1. Waiting time is 1 plus 1, 2, and then P2, 0 plus 1, and then P3, 3 plus 4, which is 7, then P4, 6 plus 3, P5, 11 plus 5, 16, and then finally P6, 0 plus 2. And the total turnaround time is 37 milliseconds, and the average turnaround time becomes 37 divided by 6, which is 6.16 milliseconds. Right, so that is how to calculate the turnaround time. And now we are done with all 5 steps: drawing the Gantt chart, calculating the waiting time, average waiting time, turnaround time, and the average turnaround time. So that is how to do the shortest job first, preemptive scheduling. Right, and now there's only one more algorithm is left to do, and it is the round robin algorithm. We already did 3 algorithms, and the links for them are given in the description. So we'll meet with a new video. Thank you.